everyone, today let's solve a card game to predict a winner. Two players, A and B, are playing a game where a stack of cards are laid out in a straight line. Each card has a positive integer and is visible to both the players. Starting from the rightmost, each player can only remove one card or n card. If the card has an integer n and the stack contains at least n cards, after the player has made its move, it is the other player's turn. This continues until the stack is empty. The question is whether the first player can employ a winning strategy regardless of the move made by player 2. For example, here is a stack of integer like this one. If player A first removes the first card from the right hand, which is 3, 1, 7, 4, and A will always be a winner, no matter player B remove one card or two cards afterwards. I will use dynamical programming to solve this problem, since it's much more simple and straightforward than other algorithms such as the depth-first search method. Let's first look at a few simple examples. From this simple example, we try to find a general pattern which can help us to write a dynamical programming code. For an empty stack, according to the problem description, the first player always lost the game. So I will mark the losing position with a cross sign and the empty stack. The next sample is a stack containing a one card. Here, I still show empty stack before. It will help us to understand the general pattern. So the empty stack is losing position, and the one card can be always moved by the first player, so the first player always wins. So we use a circle sign, means the winning position, so under the first card. Then we look at the two card stack. The empty stack position is the losing position. The first card is a winning position. However, on the second card position, since the first player can only move one card, so the first player will lose the game. So we put the cross mark under the second position. But for this two card stack, the first player can either move one card or move two cards, since the number on the second card is 2. So if we choose remove two cards, the first player will win the game. So we mark the winning position under the 2, and then this is also winning position, and then the empty stack is the losing position. Then let's look at the 3 card stack. So the empty stack is the losing position, this is a winning position, and this is also winning position. But this one is the losing position, because no matter first player remove one card or two cards, it always lost. But for this 4-2-3 3-card stack, the first player can choose the moving strategy. First remove the 3 cards and then the first player will win the game. So here is the losing position, winning position, and winning position, and the winning position. From those above examples, we can find that if the stack is left in the losing position after the first player removes the card, the first player will win anyway. In this dynamic programming code, we need a Boolean array. The Boolean array length is the length of the stack plus 1 since the empty stack position is included. Here, we are linearly going from the left of the stack till the right end of the stack. If the stack contains cards less than the integer shown on the current card, we only remove one card. Otherwise, there are two choices: remove one card or remove number cards based on the integer on the current card. Since we found that if after player 1 remove card, the stack is left in the losing position, the player 1 will win. So these two sentences represent this relationship. Last, we return the Boolean array and the last element of the Boolean array. The last element will tell whether player 1 will win or lose. Here I also want to point one thing. The Boolean array actually represents the winning strategy. For this example, the stack contains 5, 2, 3, 1, 7, 4. Since the first player can either remove one card or 4 cards, remove 4 cards, the stack will left in the losing position. So player 1 should remove 4 cards on the first move to ensure the winning position. Okay, that's all for today. See you next episode.